In this example, we're given a series that depends on the variable x. You can see the variable x in the series there. The idea is that different values of x give a different series. In this problem, we're given a specific value for x, x equals 3. And the goal of this problem is to determine where the series with x equals 3 sits in the following hierarchy, either here or here or here. And also we want to determine whether the series with x equals 3 converges or diverges. Now, one thing to keep in mind with these problems is that everything that sits over here converges. Everything that sits over here diverges. And everything that sits in the middle here, this is the gray area. We have to take convergence or divergence of things in this gray area here on a case-by-case basis. So the first thing I'll do is start by rewriting this series with x equals 3 put in for x. So we have n cubed over n to the 5th plus 1. And we're going from n equals 1 to infinity. Now, the way that we'll go about solving this is to use techniques similar to those that we learned in the limits at infinity section. So we just look at the rule an. So over here, I'll just put n cubed over n to the 5th plus 1, and we'll pull off the dominant terms. So we have n cubed over n to the 5th, which again is similar to 1 over n squared. So I'll just write that there, 1 over n squared. And so what this tells us is that, okay, since these two sequences here, not series, since these two sequences are similar, we know that their associated series either both converge or both diverge, and that they both sit in the same place in the hierarchy. So again, what this tells us that they both converge or both diverge, and they sit in the same place in the hierarchy. All right, so let's deal with convergence and divergence, convergence or divergence first. All right, so remember these, because of this fact, because we found that their rules, that these sequences are similar, we know that these two series here, there and there, either both converge or both diverge. Now notice that this here, this is a p-series. This is a p-series with p equal to 2, and 2 is bigger than 1. A p-series where p is bigger than 1 converges. So therefore we know that they both converge. So we have convergence there. Now let's determine where they sit in the hierarchy. Again, because of this fact here, we know that they sit in the same place in the hierarchy. So now let's think about this, right? So let's see. 1 over n squared goes to infinity slower than 1 over n to the 1.01. And this is because here we're dividing by more, right? We're dividing 1 by more over here than we are over here. And so therefore we know that the sum of this, or the series, (1 over n squared) sits over here. And since these rules are similar, because of this, we know that the series that we're interested in, namely this one, sits over there as well. And so our answer is converge and sits there.